All right, we'll go ahead and get started here. We're going to go through the final exam sample. This is a departmental final exam, but the questions that are on here are very similar in style to the way they're going to be asked on the actual final exam. There's going to be 15 questions here, and today we'll go through version A all the way through, and then tomorrow we'll do version B. So that way we have both versions that we've gone through on this. Final exam is going to be on this coming Thursday. And again, it's the same conditions as a test. You have 90 minutes. You have taken any time throughout the day all the way through. So what's going to happen with as far as like grades are concerned is I'm going to be emailing all of you over the weekend what your final exam score is and adjusted, and then also what your overall grade is in the class. Unfortunately, because it is a departmental exam, you're not going to be able to actually look at the exam afterwards. But if you have a burning question after I give your final grade, like what you missed, I can be happy to tell you that. But for that one, test 3, you'll be able to look over. You can view it now if you want. You can see it. I'm still in the middle of going through the scores. So I hopefully will finish by today or tomorrow, the latest. I'll let you know. So before you take the final exam, then you kind of already know what your overall grade is going into the final exam. And so if you have any questions about, grade calculations, things like that before the final exam, please go ahead, send me an email, and I'd be happy to let you know, kind of where you're at and that sort of thing. So with that, we'll go ahead and start this one. One more thing I'll let you know about is I'm not going to submit the grades to CSN until probably like next week, Tuesday morning. And so hopefully over the weekend, you'll know what your score is, and I'll give you kind of just Monday. If you have any questions about your grade or anything else, then you can email me on Monday. And so if there's anything that needs to be changed or anything like that, we can make adjustments before I submit the grades to the college, because once they're submitted to the college, then I have to do grade change forms, and it's more of a hassle to change grades after the scores have been in. So that's why I always want to let you guys know ahead of time what your grade's going to be. So in case there was a mistake or something that was made, we can catch it and correct it before the grades are actually turned in. So with that, now we'll get started on the final. So again, 15 questions similar to these that you see here. So let's start with number 1. So if there's any kind of formulas that I do on this, these are formulas that you'll need to know for the final exam. And so you should want to have those on some kind of formula sheet you should have nearby with that. Okay, so with this, we're going to use this formula, m equals change in x over change in y. So we're going to do y2 minus y1 over x2 minus x1. So again, this is an m for slope. And these points, you can label them either way, it doesn't matter. So I'll do x1, y1, x2, y2. But again, the order doesn't really matter how you do that. We're going to plug them into the formula. And we're going to do y2 negative 7 minus y1. So we're subtracting a negative. So be careful with the double negatives that we have on this. Negative 7 minus a negative 4. On the bottom, we have the difference in the x's. Negative 3 minus 3/2. So on top, negative 7 plus 4 will give you a negative 3. Now on the bottom, we'll have to do some common denominators. So I'll do that down below here. So if you do that, we'll multiply this by 2 over 2. So what we'll get is negative 6/2 minus 3/2 is negative 9/2. You'll get when you do that, or you could just do that in your calculator, use the fraction button on there to do that. When you divide a fraction, it's the same thing as multiplying by the reciprocal. So we need to multiply this by 2 over negative 9. The negatives are going to cancel out. We can also cancel out a 3 from that. and you'll end up with 2/3 as your slope. Now that's not the answer for this, because remember they want to know, it's asking you for the equation of a line. So if you just put 2/3 down, that's not correct. Okay, so you need the full equation for it. Well, to do that, once we have this, we can use y minus y1 equals m times x minus x1. Okay, so we can use that formula. And so it doesn't matter which one of these points that you use. You can use either the first or second. Now, in this case, I have this labeled as x2, y2, but I can actually use that in this formula. It doesn't matter which one of these are arbitrary labeled x1, y1. We can put those into here to get the answer. So I would do y minus the y here, y minus -7 will be y plus 7 equals 2/3 x minus -3 would be a plus 3. And I'll just erase this here. Hopefully you have that down already. And then we'll just continue with it. So we have that. And then we want to solve for y because we have to put it into y equals mx plus b form. So y plus 7 equals 2/3 x. And then 2/3 times 3, the 3's will cancel. So you just get a plus 2 there. And if you subtract 7 from both sides, you'll get the final answer, which is 2/3 x minus 5. Okay, so that would be your answer in slope-intercept form. It's not going to ask you to graph this. It's just going to have you find the equation only, and that's it. That's number one. Number two, okay, they're going to give you two kind of functions, may or may not have fractions or square roots. This is just an example that's given, but in this case, we want to find this information. It's asking for the domain of f, the domain of g, and then the domain, or not the domain, you want to calculate this f plus g of 2. So first thing is domain. The domain is talking about what values are defined in the function. So they're talking about specifically x values when we have domain. So we want to know what x values are allowed in f and what x values are allowed in the g. So this first one, notice that we have a fraction on the bottom. So if you have a fraction, we know that the bottom cannot be equal to 0. You can't have division by 0. So x cubed plus 16x cannot be equal to 0. We're going to factor out an x from this. And we get that. We get x times x squared plus 16 not equal to 0. Then we just have both of them. We already know here's one number that cannot be allowed is x. We put an x of 0 in for x, so we have division by 0. So we know that's one number that can't be included. I know that x squared minus 16 or plus 16 is not equal to 0. Now what happens is if you take that to the other side, we get x squared is not equal to -16, and x is not equal to plus or minus the square root of -16. Now that's an imaginary number on this, but it's not possible for you to have that anyway. Domain is talking about real numbers only. So if you get an imaginary number, then we're not going to worry about that. That's not going to be part of our answer. So we only have one number that's not allowed. X is not equal to 0. So then what you would do is you'd write this in interval notation, all the numbers before 0, all the numbers after 0. And that's it for that one. The next one is we want to find the domain of g. Okay, now for this, we have a square root. We don't have to worry about division by 0 on this problem because we got a 45 on the bottom, so that's never going to be 0. But the top one, we have a square root. So we have this one requires you to use an inequality. Okay, we're going to use greater than or equal to 0. Now notice the square root is on the top of the fraction. If it's on the top of the fraction, then we have greater than or equal to on it. But the difference is, when we do this one tomorrow, 2b, that's different because this one's going to require a greater than symbol, but not the equals because you've got the square root on the bottom of a fraction. So that's the difference there. So on the bottom of the fraction, you just use a greater than symbol. If it's on the top of a fraction, or maybe if there is no fraction at all, then you're going to use greater than or equal to. That's the difference there. Okay. It's okay to have a 0 on top, because 0 divided by anything is 0. You just can't divide by 0. That's the difference there. So with this, we're going to solve that for x. So we get 3x greater than or equal to 4, and then x is greater than or equal to 4/3. Okay, so x is greater than or equal to 4/3 means that all numbers greater than 4/3. So we're going to put a 4/3 here, and then that's going to go to infinity. So 4/3 is a bracket here because you have the equal sign underneath. So 4/3 is okay to include here, and that would be your answer. Now for the third part, you have f plus g of 2. Now the way we're going to do this is this is the same thing as f of 2 plus g of 2. That's what that means, f of 2 plus g of 2. Okay, so all we have to do is put a 2 into this one, put a 2 in the second one, add them together. All right, so we've got so f of 2 would just be 2 times 2 minus 7 over 2 cubed plus 16 times 2, like that. And we'll just work this one out. That's going to be -3 on top, and at the bottom we have 8 plus 32, so we get a 40 down below for that one. Now let's do g of 2. Square root of 3 times 2 minus 4 over all this over 2, or I'm sorry, 45. 45 there. 6 minus 4 is square root of 2 over 45. So we get -3 over 40 plus square root of 2 over 45. Don't worry about common denominators. If you get something like this, it's not necessary to get common denominators. So we'll leave our answer like that. You don't need a decimal either on these. Okay, they want the exact solution, and so it's okay to just to put that in as is, just like that. So we'll just leave our answer as that. That's the exact answer. All right, next one we'll do is this has difference quotient. So you want to know the difference quotient formula that will be provided for you on the test. So it's going to have that somewhere on there, but this is what it is. You can always refer back to it. But this is it. So in order to do this, we have to find f of x plus h, and I'm going to do that off to the side over here before I put it into the difference quotient formula. Now that is 3 minus 2 times x plus h squared. Got to be careful on this with your order of operations. Okay, so you don't want to do 3 minus 2. You can't do that because the 2 is connected to multiplication. We know multiplication comes before addition. In fact, exponents come even before multiplication. So that's why you're not allowed to do 2x plus 2h. Can't do that either. So we want to take care of the exponent one first. So we're going to just leave the 2 out there, and then I'm going to multiply this. So remember that's x plus h times x plus h. It's not just going to be x squared plus h squared. You have to FOIL it all out. So it's going to be x squared plus 2xh plus h squared. So that's expanding that all out by FOIL method. Next, we're going to distribute the -2, -2x squared, -4xh, -2h squared. Now that's about as far as we can go because there's no other like terms. So now we're ready to come back to the difference quotient and plug this in here. So the difference quotient formula, we've got 3 minus 2x squared minus 4xh minus 2h squared. All this right here is your f of x plus h. So we have all that. Then we're going to put a minus sign because that's in the formula. And you're subtracting the entire f of x that we have here, 3 minus 2x squared. This is your f of x. And then all that's over h. So now it's just a matter of simplifying this. Remember that you're subtracting the entire f of x. So you have to distribute that minus sign into each one. So we'll do all this on top, minus 3x plus 2x squared. All that over h. By doing that, we can now cancel some things out. The 3's cancel. 2x squares are going to cancel. What's left over is something that we can factor out in h. So for this part, that everything else is gone, so we just have this part. I'm going to factor out in h. We get negative 4x minus 2h all over h. And the h's are going to cancel. So your answer is going to be 4x minus 2h. And there's a negative 4. Yeah, negative 4 minus 2h. Okay, so that's going to be, that's your answer there. Okay, so there's no special notation you need for difference quotient. You can just put that in there. Most of the time, you are going to have an h in there as part of your answer. So that's okay to have. Number 4 is one that we have rational functions, so kind of something similar to what we had on the last test here. So this be intercepts, asymptotes, and a graph they want you to do on that. And there's also an additional question like domain and ranges and stuff like that. So we'll answer all that after we do the graph. So this is what we just went over on our last test. We'll review this again. If you want to find the x-intercept with a rational function, you're going to take the top and set it equal to 0. So 1 minus x equals 0, x equals 1. Then if you want the y-intercept, that's just how we do every other one. Just put a 0 in for x. And so we get f of x is the same thing as a y. So y equals 1 minus 0 over 0 squared minus 9. That means we get negative 1/9 as the y-intercept. Now it does, I believe it does ask you to write this as like a coordinate. So if it does, then you can just put it in like this. And then this is 0, negative 1/9. So yeah, this is coordinate form you want to put in for these. Okay, so those are 2 points on the graph itself. Next, for the asymptotes, for the VA, you take the bottom and set it equal to 0. So x squared minus 9 equals 0, x squared equals 9, and x is equal to plus or minus 3. Now this one, you do need to put the x equals, it has to be an equation of a line there. And then HA is going to, we use these rules we talked about in class for that. And it has to do with the highest power on top and the highest power on the bottom. In this problem, okay, we have a rule number 1, which is n is less than m. So this number 1 has to do with, in lecture, I gave a 1, 2, and 3 rules about that, so you can go back and check that. But in this case, if you have n is less than m, which it is, so the highest power on top is a 1, highest power on the bottom is a 2, then you end up with y equals 0 as the equation for the horizontal. Does f cross the horizontal asymptote? Let's answer that after we graph it. Okay, so we want to put all this information on there. We have a 1, 0 is the x-intercept. We have a 0, negative 1/9, which is about right here. Okay, so that's the y-intercept. For the VA, we have 3 and negative 3. Okay, so here is negative 3. Let's make that a little straighter. And then we have 3 here. And then we've got the horizontal asymptote is at y equals 0. Now, in order to know what this graph does, we have to do a couple test points, particularly on the ends. We want to know whether the graph is above or below the x-axis on each end. So in order to do that, we need a test point. So we're going to do a test point. We're going to test x equals negative 4, and we're going to put that into the original function. Okay, so that's going to be y equals, we have 1 minus negative 4, and the bottom we have negative 4 squared minus 9. So just putting that into the original function. and you're going to get a 5 on top, and this is going to give you positive 16 minus 9 is 7. So we get a 5/7. So we get negative 4 and 5/7 would be that's the first point we have there. All right, so now we know that the graph has to be in this section. Now the other thing that we're going to do is we're going to test x equals 4, and it's something to the right of the other vertical asymptote. Y equals, we have 1 minus 4 on top, and then 4 squared minus 9. 1 minus 4 is negative 3. We get 7 on the bottom. So 4 and negative 3/7 is an actual point on there. So 4 and negative 3/7 will be about here. So now that tells us that the graph is going to be below the x-axis. Now we just have to tell what happens in the middle. Again, in the middle, I mentioned this before, if you have two vertical asymptotes, then these are the 4 shapes that could be in the middle: a U, upside down U, or these ones that look like a cube. And so the way these dots are laid out here, the only one that would work is the cube shape. So we don't need to do test points for that. We'll just fit that one in the middle, just like that. It can't be the U shape, because if it went down and went back up, that means it would cross the x-axis somewhere again. And we know that's not possible because of the way the points are set up here. We only have one x-intercept. So now that we've seen the graph, we can go ahead and say, yes, okay, F does cross the horizontal asymptote. It crosses right here in the middle. That we know that because we have an x-intercept there. So of course it's going to cross at that point. So we can say yes. Okay. Let's do the domain. Now domain is talking about everything except for the vertical asymptotes. Where there's a vertical asymptote, you've got division by 0. So we can't include 3 or negative 3 in our answer. So the way that would look like in interval notation is you would include everything before the negative 3, in between, and then afterwards. So it's going to be negative infinity to negative 3, negative 3 to 3, and then 3 to infinity. All right, so basically everything except for 3 and negative 3. Now the range is going to be negative infinity to positive infinity. Now the reason why, now sometimes some of these, you don't include the x, I'm sorry, you don't include the place where it has the horizontal asymptote. Now there are some that are like that, but we already know the graph does cross through, and because this is a yes, that means it's going to include everything from negative infinity to positive infinity. So that would be the range. So these 4, you probably want to graph first and then answer the other questions. It's going to be easier if you can read that off of a graph. So that's your answer there. Number 5 is a piecewise function, but the good thing is that it's not going to ask you to graph that. It's only going to ask you to do these 3 questions only. So no, you don't have to worry about graphing any piecewise functions, just working with the compositions here, just evaluating it. Now the way you do this is you look at the number that's inside the parentheses, and then you see which of these conditional statements that number would belong to. And that's going to tell you which equation that you're going to use. So if it's 0 is only included in the top, because we have a greater than symbol on the bottom, but that's not included here. So it's only the first equation. So we're going to put 0 into the x squared. So 0 squared equals 0. That's the answer. You don't have to show your work when you type this in. You can just put the final answer in 0. That's okay. All right. 9. And 9 is greater than 0, so it would only work with the second equation. And we're going to get -3. It's not plus or minus here. There's specifically a minus sign out front, so you only have a minus on your answer. -4 is less than 0, which means we'll have to use the top equation. So -4 squared will give you 16. Okay, so that would be your final answer. No graphing. Again, you're just going to do an evaluate problem only. All right, number 6 is going to have questions similar to this. It's going to ask you to read a couple values off the graph. It's going to ask for relative max, relative min, and then increasing and decreasing. But it's going to be off of a graph only. You're not going to have any equation to work with here. Just only a graph. Okay, so it says find f of -2. Okay, this is asking for the y value when the x is -2. This is an x value inside here. Okay, so x. So if that's an x, and your answer here is going to be a y value. When x is -2, go there and you go on up until you hit the graph. It's going to happen at 4. Okay, so right here at x value -2, the y value is 4. For B, it says solve for x if f of x equals 8. Now this is telling you the y value, so now it's asking you for what y value, or what x value will give you a y value of 8. Well, here's 8 here. Okay, and we're just going to follow that over. So we hit the graph here, and then we go down and -6. Okay, so you put -6 as the answer. When the y value is 8, the x value is -6. Find the coordinates of the relative minimum. Okay, relative minimum means we have a decreasing part and we have an increasing part. So relative minimum is going to occur right there at that point. Okay, it goes down and it goes up. So this part though, like here, okay, something to point out, if you've got a flat line like this, that's not considered a relative minimum, at least not in this class. We're not going to say it's a relative minimum because we don't have an increasing part. It goes down, but then it stays flat. And then it stays flat and goes up. So we're not going to call these relative minimum. It has to be specifically decreasing and increasing afterwards, and we don't have that in this case. But there is one relative minimum that's going to be at -4, 2. Okay, so you're just writing the coordinates only. You don't have to worry about the ones the way we did it before when we did this in our class with the tests. We had some questions like, it would ask you for x and y values like separately. You're not going to have that kind of question here. It's going to ask you for the coordinate. So just write down the coordinate and that's it. Increasing, you're looking for the part of the graph that's going uphill as you move from left to right. We have one section. Here's the first section we see between -4 and -2. Okay, so now notice that coincidentally, we get the same answer as we have up here. But I just want to explain that these are two totally separate things. This is an x and a y value. That's a coordinate that's on the graph itself. These are both x values because we're talking about an interval here. Between the x value of -2 and the x value, -4 and -2, between those x values, the graph is increasing. We also have an increasing part that's going from 4 to 7. Okay, there's a closed dot there. So actually, if you want to include put a bracket on the end, that is actually correct, because that point is included. So a bracket or a parenthesis, either one of those, I would take that for an answer. Okay, so because a closed circle, again, the bracket is okay for that. Decreasing. Now, this is different than the one we just did over here. This has a closed circle, but notice the one on the end has an arrow going up. Now, because of an arrow, that means that you're going to use negative infinity. So it's decreasing between negative infinity and -4. Okay, so it keeps going up forever. It means it'll get wider and wider forever. And that means it's going to eventually use up more x values going this direction. So that's why we say negative infinity up to 4. But that's not the only place it's decreasing. We have another spot right here between -2 and 0. Okay, this is another spot where the graph is decreasing. Where it's constant is where you see a horizontal line. That's just between 0 and 4. We are going to use parentheses on these because, again, wherever you have a split between increasing, decreasing, or constant, you always put a parenthesis there because at that very spot, the graph is not increasing or decreasing at that point. So that's why we will just put parentheses around those. We don't include those. All right, next, moving on to number 7. Okay, now number 7 is one where they're going to give you some kind of quadratic, and you're going to read some information off of the graph. So you don't have to actually graph a quadratic because one will be drawn for you already. Okay, so from this, it says choose whether the graph has a maximum or a minimum, and then they want you to actually find what it is, a max or min. Well, we see here that the graph goes up and it goes down, so it is going to have a max. So I would circle the max, and then I want to write the coordinates of it. Okay, so all these are in terms of 1. So I have 1, 4 is the coordinate at this point, but the max or min is only a y value. So we're going to put a 4, and that's going to be your answer. So let me get rid of that box here. Yeah, 4 we have. Okay, so we have, that's the maximum, that's the highest y value you see. Okay, X-intercepts, we can read those off the graph here and here. Crosses at -2, and we'll put these in coordinate form. -2, 0, comma, and then 6, 0. You don't want to put a U symbol here because a U symbol is only for intervals. This is coordinates. Okay, so coordinates you're reading off the graph, you just put a parenthesis to separate those. Y-intercept is at 0, 3. The vertex happens to be at the maximum on this. So that's 2, 4. We can just read that off of the graph. Axis of symmetry, you always start that with an x equals, and you just put the x coordinate of the vertex. X equals 2. Domain and range. Domain is talking about all the x values the graph uses. This is going down both sides forever there. So because of that, the domain is going to be -infinity to +infinity. There's no division by 0, asymptotes, nothing like that we have to be concerned with. So it keeps going this way and it keeps going this way. So because of that, -infinity to +infinity. Then we have the range. Okay, range is talking about the y values the graph uses here. Well, it's going to go down to, it's going down, so it's going to go down to -infinity. But the highest point it reaches is going to be our max value. I already said the max value was 4. So it has to do with your range. It's going to be from -infinity to 4 with a bracket. That's what we have there. Now we got one more problem we're going to do here. It says, write the function's equation in the form a times x squared minus x. Okay, so this here, okay, I already know that I can get part of my answer because this is in the vertex form. And we already have the vertex. The vertex is h and k. So I don't know what the a value is. I'm going to leave a space for that, but I can already put a 4 and then plus a 2 here. So I already know most of what it is. I don't know what the a value is. And what you can do is you can use a point. Now, it doesn't matter what point you use. You can use x-intercept, y-intercept. We already have a point. We already know 0, 3 is on the graph. So what you're going to do on this is I'll just do that up here. So y equals a times x minus 4. You already identified what that was. We have this. I'm going to put a 0 in for x and a 3 in for y. Okay, so I have a times 0 minus 4 squared plus 2, like that. I'm going to subtract the 2 the other side. Actually, what I'll do is let me do this part inside first. So 0 minus negative 4 squared is 16. So I have 16a plus 2. So then we're going to subtract both sides from that one. I'm sorry, you know what? I put the wrong number in here. I switched these. My apologies. I said h was 2 and k was 4. So I actually switched these. So let me actually fix this here. This should be a 2, and this should be a 4. Yeah, it's h and k. So I switched those. My apologies on that. So this should be a times x minus 2 squared plus 4. So now we're going to put in the 3 goes in here. 0 minus 2 squared. I was wondering why that number was so big. That's why I double checked it. 3 equals 4a plus 4. We're going to subtract the 4 from both sides. We get negative 1 equals 4a. And if you divide, you get negative 1/4 is the a value. So now we know that this is negative 1/4 that goes in front. So now we know what the exact equation is that would create this graph. Negative 1/4 x minus 2 squared plus 4. So that is a type of question that they'll ask you on the final exam. They're going to ask you to come up with the equation for a quadratic. And that's how you do it. You just use the vertex and you use another point that's on the graph. So again, we could have used negative 2, 0, 6, 0. It doesn't matter. Any point that's on the graph is what you can use. Okay, anything except for the vertex, of course. So that's what you want to use there. Let's go to 8. Okay, so 8 is one where you're using a composition function. And for that, it says find two functions, f of x and g of x, such that if you put them together, you're going to get a composition with that, f of g of x. And the test is only going to have f of g of x on it. This might have a couple different functions on it, but in this case, something like that is what it'll have. So when you identify these, your g is always the inside function. So whenever you see something inside of something else, like maybe something inside of a square root, or if you've got something inside of parentheses, that's automatically what you're going to put for g of x. So 7 minus 9x is what that's inside. Now, in order to get the f of x, what you're going to do is you're going to take, so here, you're going to take the original, so here's the original function. What I'm going to do is remove the part that was inside. So I'm going to get rid of the g is the inside function. I'm going to remove the g and then replace it with an x. And that's how I get my f of x function. Okay, that's all you have to do for that. So inside function automatically is your g of x. And then we just do this part down here. So your f of x is basically equal to the original function. You take out the g, the space, replace it with an x. So there you go. That's your answer, 2 over x cubed. All right, number 9, we have graph a polynomial. Okay, so it's going to have you ask you for the leading term or the power function, and it'll have some, it'll ask you for these two. So for this, the zeros are what makes each parenthesis part equal to 0. So basically just the opposite signs of what you see in the parentheses here. It's a -1, it's a 1. It's negative. If it's +2, it's going to be a -2. Okay, so we have that first of all. Multiplicities are the powers that are on each of these factored pieces. There's a 2 on that one. There's a 1 on the other one. So we're going to do a 2 and a 1 for those. The degree you get by adding the multiplicities together. So this is going to be a degree 3. The y-intercept you find by putting in, you find this by making the x equal 0. So I'll do that down here. -2, 0, 0 minus 1 squared, 0 plus 2. So I have -2, and then this is going to be -1 squared, and then times 2. So if you multiply all that together, you're going to get -4. So that's going to be on that. We'll write it as a coordinate. Again, just follow the instructions on my open math, whether it asks you to write as a coordinate or not, it'll tell you. So 0, -4 will do. Now the leading term, the power function, you don't have to multiply all this out. What we're going to do is we're going to look at the different pieces that we're multiplying together here. So I have a -2 out front. If I were to multiply the second term, I would get x squared plus 2x minus 1. Or x squared, minus 2x plus 1. So the main thing is the leading term of this, if I multiply it together, is just going to be an x squared. And on the end, I have just x plus 2, so that's multiplied by an x. So if I multiply all this together, -2x cubed is what you're going to get for the answer there. On the test, you're going to have some kind of a multiple choice thing that you'll have on this. Okay, so again, it'll be multiple choice you'll choose for something like this. We're first going to plot the points. So I have a 1 and a -2. So -2 I have and a 1. That's where the graph crosses. I also have a 0, -4 crosses here. So those are the intercepts that I have so far. Now, if I look at this, I have the degree is odd, and my a of n would be the number in front of the leading term. It's the coefficient on the leading term that we already identified is -2. So I know that a sub n is less than 0. Well, from those little charts I gave you, if the degree is odd, a of n is less than 0, the graph is going to do this. That's in that section where we graph polynomials. I gave you some different models depending on whether a degree is even or odd, and the a of n is greater than or less than 0. So in this case, it's going to go up, and it's going to go down there. So for this, when I draw this, I know that the graph is going to be coming down. Now, what I also know is the multiplicities tells me whether the graph is going to cross or touch. And so it's not going to ask you for that on the final exam, but we should know that this one is at 1, the graph's going to touch, and then at 1, the graph is going to cross. So at -2, the graph is going to cross. So I need to draw that the graph's going to come down and do something like this. It's going to come down through this. Now, I don't know exactly how far down this goes. The graph may, it may go down to here or something. We're not really sure. So I know it's going to come down to some point. I'm not really sure what it is. It's going to curve. It's going to go through this point, and then when it gets up to here, at that point there, the graph is going to touch only, which means the graph has to reverse directions and go down this way. So that's about what the graph is going to look like. It's going to come down here. It goes up and it goes down because of end behavior we found. And we've got these two intercepts. If it's even multiplicity, it touches. Odd multiplicity, it crosses, as we can see the two differences there. So again, you're just going to pick the right graph. It'll be a multiple choice thing you'll choose. For number 10, it's going to give you one of the zeros. So given one of those zeros, it's going to ask you to find all the other ones by using synthetic division. So we did these problems originally in class. We talked about the rational zeros theorem we did before. You don't have to know that in this case. And you don't have to write the factoring form. You just have to now specifically you do have to use synthetic division and factoring. It does specifically say. So because it says factoring, that means you don't want to use a quadratic formula here. You have to follow the instructions and do the instructions that it tells you to do. So it's saying specifically use synthetic and factoring, which means that when I check your work, I want to see synthetic division and factoring. If you don't show that, you're not going to get full credit on this problem. So that's something to keep in mind on this. So let's do that with synthetic division and factoring. Okay, x equals -2. We're going to put that in the little box here. And in synthetic, we have 6, -5, -29, and 10. Always be sure that you put in any kind of place keepers if you need it, and make sure they're descending powers. It is descending powers. There's no nothing missing, so we don't need any place keepers here. Drop down to 6. We multiply these and put that in the next column. You're always adding when you do synthetic division. Okay, so -5 plus -12 is -17. You multiply this. So we multiply that. That's going to give you the 34. We put that underneath the next. So that goes underneath the next column here. And then we're adding. So again, it's always adding when you're putting these in for that. So you get a 5 here, -10, and you get a remainder of 0 as expected. Now, if you don't get a 0, you want to go back and check your work because something's wrong. You should always get a remainder of 0 when you do these because it's telling you that it has a 0 of -2. That's going to turn that into 6x squared minus 17x plus 5. Now, again, it's telling you specifically use factoring here. So you want to do factoring on this step. Now, you can factor by doing either some of the methods we talked about earlier in class about bottoms-up method or grouping method, or you can do it this way, which is a trial and error method. Okay, so trial and error, you have like 2x and 3x here for that. And then you look for factors of 5, so we can put a 1 and a 5 here and try that first. If I do that, I get 6x squared, I get a 10 and a 3. That doesn't add up to 16. So then I want to switch the order around. And so I'll put a 5 here and a 1 there and try that. 6x squared, I have a 2 and a 15. So yes, if I make both of these negative, that is the right combination to get me the -17 in the middle. You can always multiply it out to make sure you got what you originally started with. In doing so, you have 2x minus 5 equals 0, 3x minus 1 equals 0. So x equals positive 5/2, adding the 5 divided by 2, add the 1 divided by 3, you get 1/3. So that's going to be your two answers, 5/2, 1/3. Okay, so that's going to be it there. Believe it or not, there is going to be a problem. Again, this is the departmental final. There is going to be like calculator questions on here. So yes, you can use a calculator on these. So these are ones where 11, you don't have to show any work because you're just putting that into the calculator. So this is really the only, well, actually 11 and yeah, that's really the only one. This number 11 is the calculator question that's on there. So you don't need, that's the only problem where you don't need to show any work. And because of that, it's either all right or all wrong. So there's only one option on this. So I won't be giving any partial credit on that one. It's just right or wrong, but you can again just put it in the calculator. This is a 1.2. It might be hard to see that decimal point here. So it's 3 raised to the 1.2. So you want to use, again, the calculator button. You want to use the caret key or e to the x, x to the y, or y to the x, whatever these buttons that your calculator might have. That's what you want to use. So put the base in there, hit one of these buttons and hit the 1.2 on it. And it says round your answers 4 decimal places where appropriate. Okay, so 3.7372 is what you're going to get for I. And then for the second part, you're using the ln button on your calculator. And you want to make sure you put parentheses around this 10 divided by 3.5. You could also do that first and then divide it, but you'll get 1.0498. Okay, that's what your calculator will give you. Again, that's 4 decimal places you should get for that one. So be familiar with calculator, make sure you have some kind of a scientific calculator, or graphing calculator is okay as well. Either one of those is allowed. Number 12. This one, there's really not a whole lot of work to show for these either. For these, you're just changing it from log form to exponential form. That's all we're doing on this. Now remember that the ln here, that's the same thing as a log base e. So we're going to first do this and change it from ln to log base e. Now we're just going to change it from log form to exponential. We have e to the third is going to equal 5x minus 6. Now we're not solving this. Okay, so it says do not solve for any unknowns. All we're doing is putting in the equation as is. So that's going to be it. That's what you'll put for your answer. E to the third equals 5x minus 6. Okay, and that's it. That's your whole answer. Next one, we have ln 5x equals 4. All right, so again, we're going to change that to, not ln, we're going to change it to log base e. 5x equals 4. So change it from log to form exponential. E to the 4, the base, raise the number after the equal sign, equals whatever you have inside the parentheses. So e to the 4 equals 5x. And again, that would be it. So it's not really a whole, this is really the only work you could show for it, is changing ln into a log e. That's really all that's needed on that one. 13 is another one where we want to change it from the, we're doing to go back in the other direction. So instead of going from log to exponential, we want to go exponential back into a log here. All right, so for this, we're going to first, the way we do this is the base of this is the base of the log. So we start with that. The exponent is going to be what goes on the other side of the equal sign. And then whatever is left over, 1 over 32, that's going to go inside of the log. Okay, so that's what you would just put for the answer. You can either put -5 equals, or you can put the log first. It really doesn't matter the order in which you write this, but that would be it. That's your answer. 14 is going to have 3 parts. Okay, so part A, B, and C on this. So let's do the first one. It says, so I'll solve for each equation. So there'll be basically 3 equations, exponential equations, log equations. So you just want to solve all those. Okay, now the first one here, we got a minus sign. The actual question might either be a minus or a plus, doesn't matter. Okay, so either it depends on if it's a minus or plus, how we use our log properties here. So minus means that you're going to do a division problem. So subtraction turns into division. So we want to do one log only, and the first one goes on top, the second one goes on the bottom. Okay, so x minus 5 over 2x plus 3 equals 0. Now we want to change it from log form to exponential. Take the base, raise the number after the equal sign, equals whatever is inside the log. Anything raised to the power of 0 is 1. So I have 1 equals x minus 5 over 2x plus 3. We can cross multiply. 2x plus 3 equals x minus 5. We can subtract the x from both sides and get x plus 3 equals -5. So again, I just subtracted the x there. And I'm going to subtract the 3 from both sides. And I get x equals -8. Now, you want to take the -8, and you need, remember these kind of problems, you need to check your answer. So if I put -8 back into the original equation, it needs to be a positive number inside. But if I take -8 and put it inside the first log, I get -8 minus 5. That's a negative number. So I can't take log of a negative number, which means that that only answer doesn't work, which means that you're going to have a no solution for that one. If the only answer you have doesn't work, then you got to cross it out. Okay, so any answer you get, you have to put back into the original one to make sure you're not getting a 0 inside. So no solution on this one. Next, we have a exponential one. Now this is one that you can use the equal bases property on, because it's one where you'll be able to write both sides in terms of the base. In order to do that, we have to first add the 27 to both sides. So 2 to the 4x minus 3 here is going to be equal to 32. Okay, so that's the first thing you want to do, is add 27 to both sides so you can isolate the exponent part. 32 we can write as a power of 2. So 2 to the 4x minus 3 is equal to 2 to the 5th power. We have the bases the same, so now we're going to set the exponents equal. 4x minus 3 equals 5. And now we're to solve that. So add 3 to both sides, we get 4x equals 8, and then x is equal to 2. Okay, so that's the answer on this. Exponential equations, you don't need to check those because the domain of exponent is negative infinity to positive infinity. So that's why we only have to check our answers for log problems. So that's what we'll, so we don't have to worry about plugging that back in. You still can put it in there just to see if it works, if you did it correctly, but in this case, we won't worry about it. We'll just leave it x equals 2. All right, now this next one down below here, this one we can't use equal basis property because you can't write both of these as the base of itself. So this one's going to involve taking a log of both sides. Now I know that on the last test we did natural logs we took on both sides, but because there's specifically a 10 here, I want that 10 to go away so I can get x by itself. What I'm going to use is I'm going to specifically take a log of both sides, log. Okay, a log with no number underneath, that's automatically assumed to be a base 10. So I'm really doing a base 10 on both sides here, but I don't have to actually show the base because a log with no base is automatically log base 10. Now what that's going to do is the negative x is going to come down in front, so we get negative x log 10 equals log 1.6. Now this part here, that's going to turn into a 1. Okay, so this right here is a 1. Log base 10 of 10, that's one of our special properties. So I just get negative x equals log 1.6. And then if you just divide both sides by a negative, we'll get our answer, negative log of 1.6. Yeah, this will actually ask you to turn it into a decimal. So let's do that one more step here to get negative 0.22041. So this is actually what they'll want the answer to be in, because I believe this one does ask you for a decimal answer on that. So 4 decimal places we'll use again, since that's what we use for the other problems. So yeah, you will need to get a decimal on that. Okay, so now we got one more problem that we're going to do on here. And so this is so the last problem in the test is actually going to be linear equations, not the nonlinear. On the last test, test 3, we did nonlinear, so that's why we're going to do linear on here for the final exam. Okay, so this is going to involve either using the substitution or elimination technique. You can use either one on something like this. In this case, it might be easier to do the elimination process on that, because if we solve for x or y, it's going to involve some fractions, and it might be a little bit more work to do because we have to deal with fractions. So it might be better instead to use the elimination here. Now you can choose to eliminate either the x's or the y's. If you see two coefficients where one is a factor of the other one, then you probably want to use that variable. For instance, 3 and 5 are not factors of each other, but 2 and 4 are. So if I look at 2 and 4, the smallest number that would divide evenly into each of these would be a 4. So 2 divides into 4 and 4 divides into itself. So 4 is the least common multiple that would have here. I want to make one of those positive 4 and the other one negative 4. Well, the bottom one's already positive 4, so I'm going to take the top equation and multiply through both sides by -2 in the bottom equation, I'm not going to do anything with. I'm just going to leave that as is. So what's going to happen is I get -4x plus 6x, or plus 6y, I should say, equals 16. This is the same. Now I'm going to add these together. X's cancel out. I get -11. I get 11y equals 22. If I divide that, I get y is equal to 2. And now I need to find the x value because I want to find the point of intersection. You can either plug the 2 back into the first equation or second equation, doesn't matter. I'll use the first one. So 2x minus 3 times 2 equals -8. So I get 2x minus 6 equals -8. Add the 6 to both sides right there, and I get 2x equals 14. So x is equal to 7. Okay, so now I have the x and the y on that, and so I get so that's hold on a second here, something's not let's see. Oh, negative, what am I doing? -6 plus -8 plus 6 is, I had that wrong. That is not, that's -2 there. Yeah, -8 plus 6 is -2, and so we get -1. -1 is the answer here. So it's -1 and 2. That is the correct answer on this. All right, so that's your final answer on that one. So apologize for that mistake over there. You gotta be, that shows you gotta be careful with your signs when you're adding things together. So -1, 2 is your final answer on that one. And so we've gone through. This is the just the first this version A. So again, tomorrow we'll do version B in class. But before we go today, does anybody have any questions on any of these problems, or need me to go back and see any of those? Any questions? All right, sounds like nobody has any questions. I'll just go ahead and end the meeting. Again, we'll have one more day of review tomorrow. We'll do version B. Enjoy the rest of your day. See you tomorrow.